Okay, this is a response to an email I got from a Year 12 student to do question 9, 2007, parts A and B. And here what we've really got is a graph, the transformation of a sine graph. We've got a sine graph that's been transformed. And we need to remember our C1 stuff, that if you put +2 on the outside, it's the output coordinates, namely the y coordinates. They're affected, and it happens really easily. It's just the y coordinates +2. The weird one is when it's on the inside. When it's on the inside, it's the input coordinates, which are your x coordinates. You put x's in, you get y's out. And you can see it happens counterintuitively the opposite to what you'd expect. So here the x coordinates would get smaller by 2. So in here we can see that the x coordinates get smaller, okay, by pi by 6. Now we're dealing with radians here, and so you need to be comfortable with the idea that pi is 180 degrees, and you really should know that pi by 6 is 30, pi by 3 is 60, pi by 4 is 45, pi by 2 is 90, and be comfortable with those phrases, those things. So I'm actually going to be going back 30 degrees. So if we notch these up, remember this is 90, hence pi by 2. This is 180, okay, so that's just pi. This is 1.5 pi, which we write as 3 pi over 2, and this is 2 pi. Now, if we're cutting this up into 30-degree pieces, okay, then it makes sense to think of these. So remember, 30 degrees is pi by 6. So a whole pi is 6 pi, okay, 6 pi out of 6. 6 pi out of 6 is 1, isn't it? So this would be 1 less than that, which would be 5 pi over 6. And likewise, 2 pi is going to be 12 sixes. So the one behind that is 11 6 pi. There's pi, there's 11, and there's over 6. Okay, I haven't got much room here. So 2 is 12 6. So 1 less is 11 pi over 6. 1 is 6 6. And 1 less is 5 pi over 6. And here, if we do 1 less, we're going to go behind 0 0. And we're going to get, okay, minus pi by 6. Or minus 30 degrees if you're thinking in degrees. 0. So let's draw here again. We're going to go 1 behind that. Okay, so half a pi is 3 pi over 6. So half a pi is 3 pi over 6. So 1 less than that is 2 pi over 6. Okay, or you can just think of it as pi by 3, which is 60 degrees. But I think it's easier if we keep everything in sixths. So this point is going to here because we're going backwards. That point, so we're going to get this line here. Then this is going to cut to here. Remember, it's a sketch, it doesn't have to be accurate. This is going to cut back to here. We haven't identified what this one is. Okay, so 1.5 6. 1.5 of 6 is 9 over 6 is 1.5. So this would be 8 pi over 6. And so this would go back, and we'd end up with this going to here, and this going to here. Okay, we're shifting the whole graph backwards. Okay, so that's part A done. I need to connect that up. But they wanted the exact coordinates between, okay, so I just moved that up there a little bit, move it between 0 and 2 pi, where this thing hits the x-axis. Well, here's the 0 line here, look. So here, just looking at the x-coordinates to start with, you can see that it hits the x-coordinates at 5 pi over 6, okay, and it hits here at 11 pi over 6. So we've got, first of all, 5 pi over 6, comma 0. Is that more like a pi? And then we've got this one, which is 11 pi over 6. Sorry, I forgot to put the y coordinate in, 0. Okay. Okay, so we've got one more thing to do, and that is we need to work out where it crosses the y-axis. Okay. And what do we know about points on the y-axis is that you're not to the right, not to the left, so your x-coordinate must be 0. So what I have to do is put into my function the fact that the x-coordinate is 0. So it's a plus sign, 6. And if you put this into your calculator, making sure your calculator is in radians, you actually get a half. But hopefully a lot of you just remember that pi by 6 is 30 degrees, and so really you're just doing sine 30 degrees, which is a half. So this point here must be 0, a half. And so my final point here would be 0, a half. Now quickly, what I did here was I've put it into my graphics calculator, sine x plus pi by 6. And I've sketched it here, and I can see what the y-intercept is. If I go to the y-intercept, I'm going to get half, which is as we predicted. And if I want to find the x-coordinates, and I go to gsolve, and I want roots, the x-coordinates, so I press roots, and I go along here, and I get 2.617, Well, unfortunately, that's the reason they asked us for the exact solutions, because they didn't want us to use our graphics calculator. But we can still check. So if you put 5 pi over 6 into your calculator, you will get that number. And if I press here, I can go to the other root here, and if I put 11 pi over 6 in here, I do in fact get 5.7. And just a quick reminder that two things I needed to do here. Once when I went to V window, I changed here. Remember, pi is 3.14, so 2 pi is 6.28, which is why I've got an x max on 6.3, done 0 here. Because the ceiling is 1 and minus 1, I did the ceiling at minus 2 and 1. And here I also checked that I was in radians. I came down here and went to where is it? Angles. There it is. Angles I made sure that was in radians.